Mechanics, paper 32, Mathematics Advanced, Monday, 19 October 2020. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credits. Question number 1. A rough plane is inclined to the horizontal at an angle alpha, where tan alpha is equal to 3/4. A brick P of mass m is placed on the plane. The coefficient of friction between P and the plane is mu. Brick P is in equilibrium and on the point of sliding down the plane. Brick P is modeled as a particle. Using the model, find in terms of m and g the magnitude of the normal reaction of the plane on brick P. And part B, show that mu is equal to 3/4. So we're given that tangent of alpha is equal to 3/4. Tangent is opposite over hypotenuse. So it's 3, opposite over adjacent. Tangent is opposite over adjacent. So tangent is 3/4, opposite over adjacent. Cosine alpha, so if we have a right angle triangle, 3 squared plus 4 squared, and square root of that will give you 5. So 3 squared plus 4 squared, and square root of that will give you 5. So cos alpha, cosine is adjacent over hypotenuse, which is 4/5. Sine alpha, sine is opposite over hypotenuse, which is 3/5. So if we look at the right angle triangle, we would see R is the upward force, which is at 90 degrees to the inclined plane, 90 degrees. And there is a downward force. And if we use this triangle, mg is a hypotenuse. So cosine of this angle alpha is adjacent over hypotenuse. So cos alpha, I've colored it purple. So cosine of alpha is adjacent over hypotenuse, and adjacent is what we want. So we can call that x. So it's x over hypotenuse is mg, and that's equals to cos alpha. So x would be mg cos alpha. So the upward force is R, and the downward force is mg cos alpha. Forces act in pair. The force pushing it up the inclined plane, the frictional force stopping it from sliding down, is F is equals to mu R. And forces act in pair. The force pulling it down is this one, which is, we can use this one, is mg sine alpha. That's the force which is causing it to slide down the plane. This angle is alpha. This one is alpha. This is 90. 90 minus alpha will give you that angle. It's very important because it's not moving up or down. The upward force has to be equal to downward force because it is staying fixed position. So the upward force is equal to the downward force. So either you say the upward force R is equal to the downward force mg cos alpha, and you replace cos alpha. Cos alpha is 4/5. When you replace cos alpha with 4/5, it becomes 4/5 mg. Or you can write it as an equation form using F equals to ma. Upward force minus downward force is equals to mass times acceleration, but it's not moving, so acceleration is 0. So r minus mg cos alpha is equal to 0. And you take mg cos alpha to the right side, it becomes r is equals to mg equals alpha. You can do it that way. So that's how you get r is equals to 4 over 5 mg. Part B, show that mu is 3 over 4. Mu is coefficient of friction. When you resolve parallel to the plane, the force pulling it up, frictional force stopping it from sliding down, is equals to the force trying to get it to slide down, which is due to the weight. So force trying to get it to, the force pulling it up is called F, stopping it from sliding, the frictional force, and the force pulling it down is called mg sine alpha. This is it, the mg sine alpha, trying to pull it down. It's not moving, so the true force, we would say forward force is equals to backward force. But we replace F with mu r, because F is frictional force, and we want to solve for mu. So we replace F with mu r, and so mu r is equals mg sine alpha. It's times r on the right. We take times r to the left, to the right hand side. It becomes divide by r. So mu is mg times sine alpha divided by r. But sine alpha is 3 over 5. And r is 4 over 5 mg, which we got from before. So r is 4 over 5 mg, and sine alpha is 3 over 5. So it will be mg times 3 over 5 divided by mg, and take the 4 over 5 to the top, is divided by 4 over 5. The mg will cancel. 3 over 5 times 5 over 4, because you flip them and change that to a times. So you end up with mu is equals to 3 over 4. QED, quod erat demonstratum, as required to show. Brick P is now removed from the plane, and a much heavier brick Q is placed on the plane. The coefficient of friction between Q and the plane is also 3 over 4. Explain briefly why brick Q will remain at rest on the plane. The forces acting on Q will still balance as M's cancel, the masses cancel. And other possibilities, any friction, the friction will increase in the same proportion as the weight component or the force down the plane. Or the force pulling the brick down the plane increases by the same amount as the friction. Brick Q is now projected with speed 0.5 meters per second down a line of greatest slope of the plane. Brick Q is modeled as a particle. Using the model, describe the motion of brick Q, giving a reason for your answer. Brick Q slides down the plane with a constant speed. You must mention that word constant speed. The speed is the same, because no resultant force down the plane, so there is no acceleration. A particle P moves with acceleration 4I minus 5J meters per second squared. At time t equals to 0, P is moving with velocity minus 2I plus 2J meters per second. Find the velocity of P at time t equals to 2 seconds. So we're going to use the Sievert equation. So we first of all write down Sievert and put in what the values we know. We know U, the initial speed, is minus 2I plus 2J. V, the final speed, we don't know. That's what we're looking for. Acceleration is 4I minus 5J, and T is equal to 2 seconds. So we use V is equals to U plus AT. We substitute U is 2I minus 2I plus 2J. Acceleration is 4I minus 5J, and the time is 2 seconds. So we remove the bracket. 2 times 4 is 8I, and 2 times minus 5J is minus 10. So we add the I component. Minus 2I plus 8I is 6I. is the same as 8 minus 2, 6i. And 2j minus 10j, it gives you minus 8j. So the velocity is 6i minus 8j meters per second. At time t is equals to 0, p passes through the origin O. At time t is equals to t seconds, where t is greater than 0, the particle p passes through the point A. The position vector of A is lambda I minus 4.5 j meters relative to O, where lambda is a constant. Find the value of t. We still write down the sievert, and then we fill in the values that we know. So the initial speed is minus 2i plus 2j. Acceleration is 4i minus 5j. The time is 2. So we're going to use this sievert equation. R is equals to ut plus half at squared. R represents the position. So we know is given by lambda I minus 4.5 j, that position from the question, lambda I minus 4.5 j. We know u is minus 2i plus 2j, and then times t plus half times acceleration is 4i minus 5j, 4i minus 5j times t squared. So we have lambda I minus 4.5j. We remove the bracket, minus 2i times t minus 2ti. And 2j times t is 2tj. Half times 4i times t squared gives you 2t squared. Half times minus 5j times t squared minus 5 over 2t squared j. We put in brackets 2t plus 2t squared, all I. So put all the i's together. 2t plus 2t squared, and put the j's together. 2t minus 5 over 2t squared j is equal, and then lambda I minus 4.5 lambda j. So we put the i's and the j's separately. And we want the j terms only. So equate j components to give equation in t only. So minus 4.5 for the j is equals to 2t minus 5 over 2t squared. So we take 2t to the left, it becomes minus 2t. We take minus 5 over 2t squared to the left, it becomes plus 5 over 2t. So we have 5 over 2t squared minus 2t minus 4.5 equals to 0. If you put this in your calculator, 5 over 2 is 2.5, minus 2 and minus 4.5, you will get the two answers of 1.8 and minus 1. So you use your calculator to solve the quadratic. Hence, find the value of lambda. Equation in lambda only with no i's in them. So we want an expression for lambda must be a quadratic in t. So we solve the problem by substituting the t value into the I component equation to give an equation in lambda only. So this is what we want to do. We want lambda is equals to minus 2t. We want the one only in I, so the lambda is equals to minus 2t plus 2t squared. So we know t is 1.8. So we substitute 1.8 for t. So 1.8 goes in for t. So it becomes minus 2 times 1.8 plus 2 times 1.8 all squared. That will give lambda to be 2.88 or 72 over 25. That's question 2a. Question 2b. and question 2c. Question number 3. At time t seconds, where t is greater than or equal to 0, a particle p moves so that its acceleration a meters per second squared is given by a equals to 1 minus 4t I plus 3 minus t squared j. At the instant when t is equal to 0, the velocity of p is 36 I meters per second. Find the velocity of p when t is equals to 4. So we've got here some equations or formula that you can use. When you want to find velocity, you integrate acceleration. When you want to find velocity, you integrate acceleration. So you integrate acceleration with respect to t to obtain velocity. And then you put the constant of integration. So we put acceleration 1 minus 4ti plus 3 minus t squared j. And this is the formula for integration. You add 1 to the power, you divide by the new power. So the power is n plus 1, you divide by n plus 1. That's the process for integration. So when we integrate, integral of 1, imagine it's like x to the power 0. You add 1 and you divide by 1. So it's just t. We're using t in this case, so let's t to the power 0. When you integrate 4t, you t to the power 1, you add 1, it becomes 4t squared divided by 2. And then I. When you integrate 3, it's like 3t to the power 0. So you add 1, it becomes 3t to the 1 divided by 1, which is just 3t. T squared, you add 1 to the power, it becomes t cubed. You divide by the new power, 3. And then j plus the constant of integration, c. So if you are given initial condition or boundary condition, which allows you to find c, you go ahead and substitute. But we know at t is equals to 0, the velocity of p is 36 I meters per second. And you can check that out by substituting 0 for t. If you put 0 for t, 0 for t, and put 0 for t, that will give you 0, 0 plus c, and then you get c to be 36. So you know c is 36. So you can write now your equation, including the constant of integration. So you got your v for velocity, t minus 2t squared I, plus 3t minus 1 over 3t cubed j, plus c is 36I. So very important, velocity, t minus 2t squared the same, the plus 3t minus 1 over 3t cubed, and plus 36I. Now we want to substitute t is equals to 4 when t is equals to 4. So we will put 4 minus 2 times 4 squared plus 3 times 4 minus 1 over 3 times 4 cubed plus 36I. If you put that in your calculator, 4 minus 2 times 4 squared is minus 28I. 3 times 4 minus 1 over 3 times 4 cubed, it gives you minus 28 over 3j plus 36I. Minus 28 plus 36 is like 36 minus 28, which will give you 8I. So it's 8I minus 28 over 3j meters per second. And that's the velocity. Part 3b. Find the value of t at the instant when p is moving in a direction perpendicular to I. Equate I component of v to 0 because perpendicular to the I. So the I component, you equate it to 0. Let's put the I component together. The I component is t minus 2t squared I plus 36I. Those are the I components. So t minus 2t squared plus 36I is the I component of the velocity. And we put that equal to 0 because it says perpendicular to I. And now we have t minus 2t squared plus 36 equals to 0. We can swap positions so it looks like a quadratic. The minus 2t can come in front. So it becomes minus 2t squared and plus t plus 36 equals to 0. So in your calculator, -2 is for the A, 1 is for the B, and 36 is for the C. And when you put that in your calculator, you will get two answers, 4.5 and -4. So we will reject -4, and your answer T is 4.5. At time t seconds, where t is greater than or equal to 0, a particle Q moves so that its position vector, r meters relative to a fixed origin O, is given by r is equal to t squared minus t I plus 3tj. Find the value of t at the instant when the speed of Q is 5 meters per second. So you want to differentiate r with respect to t to obtain velocity. So use this formula. Velocity is equals to dr over dt. So we want to differentiate t squared. When you differentiate t squared, you get 2t. Power to the front, 2 comes in front, and you minus 1, so it becomes 2t. When you differentiate t, it just becomes -1. When you differentiate t, it's like t to the 1 comes in front, and then you subtract 1, so it's just 1. And when you differentiate 3t, you just get 3. So your velocity now is 2t minus 1I plus 3j. Now, if you look at this triangle on the right hand side, this 2t minus 1I could represent this side of that triangle, and the 3 could represent that vertical side for the j. So using Pythagoras, 2t minus 1 squared plus 3 squared is equals to the 5 squared, which is giving the speed of Q, the magnitude. So 2t minus 1, we write it twice, and you expand it, it becomes 2t times 2t, which is 4t squared. 2t times -1 is plus 2, -1 times 2t becomes -4t. -1 times -1 gives you +1. And 3 squared is 9. 5 squared is 25. You take it to the left, it becomes -25. So 5 squared is 25. You take it, it becomes -25. So 1 plus 9 minus 25 is -15. To solve this quadratic, you use your calculator. A is 4, B is -4, C is -15, and your calculator will give you two answers, 2.5 and -1.5. You reject the -1.5, and your answer will be 2.5.